Go. So today we'll talk about serverless. So before we begin, let's see what we'll see today on this talk. First, we'll see what is serverless, because I'm pretty sure that most of the people don't know that. Then we'll try to explain how it works. After that, of course, this is JavaScript conference, so we want to see how it works with Node.js. After that, we'll see why is it important. And finally, when should you use it? And before we start, I should probably introduce myself. So I'm Slobodan Stojanovic. Well, I work as a CTO at Cloud Horizon. It's a small Canadian-Serbian company, so we are doing a bunch of web applications. Some of them are serverless, not all of them, of course. We are also doing some small products now and things like that. Beside that, I'm organizing JavaScript meetup in Belgrade, Serbia. And you can follow me on Twitter, and you can see a bunch of open source things on GitHub. And before we continue, I would like to ask a few questions. So I would like to know something about you. First, this JavaScript conference, so it's obvious that most of you are JavaScript developers. But how many of you are working with Node.js? Ooh, awesome. The second question is, did anyone try serverless? Any way of serverless? Nice. Yeah, and the last question is, who read the book, Hitchhiker's Guide to the Galaxy? Ooh, nice. OK, so let's go. Is this just another serverless talk? And why do we need just another serverless talk? Because most of the conferences now have some kind of serverless talk. So I don't know about you, but my story with serverless started maybe a year and a half ago. And a good friend told me about this thing, and he was very passionate about that. And I was very skeptic, because my setup was really good. I was working with Happy.js and Koa framework, and I was really happy with that. But after some time, because I really respect that guy, I tried to do something small with AWS LAMBDA. And shortly after that, I started building almost everything with serverless. You shouldn't build everything with serverless, but you'll see. So to understand serverless, you basically just need to trust me everything I say today, but no. So what is serverless? Let's start with that. Is it just a buzzword, or there's something more than that? If you try to Google that, first you'll see platform as a service. But that really doesn't explain anything. There's a bunch of things that are platform as a service. Some of them doesn't have anything with JavaScript or programming. Then if you continue Googling everything, you'll see function as a service. That's a bit better thing that explains serverless, but still, what kind of function? What does that function mean? How does that work? So it's really confusing. And I like explaining things with something simple. And who played with Lego bricks? Of course. Who stepped on a Lego brick? Yeah, so let's try to explain serverless with Lego bricks. So is serverless like stepping on a Lego brick? Really? It probably can be, but for me, it's not. So first, let's imagine that we have 4x4 Lego brick as our server. It doesn't have to be physical server. It can be cloud server or anything like that. And how do we build our monolith application? So most common applications, by doing some different kind of different parts of that application. So imagine that green part is, for example, user management. Then we have yellow part that is like maybe payments system and things like that. Then we have some orange part that can be, for example, thing that sends emails to our customers. Then we have core feature of our application, and we have some smaller services, like, for example, something that will assemble everything to PDFs and things like that. And since we bundle everything on one server, we glue that together. That's how we build our monolith applications. But after some time, people start using that application, and then we need to scale it. So how do we do that? Basically by just creating a copy of whole application. And it's not that simple. We need to make sure that our state is somewhere else, because we are not able to scale the database the same way. Also, we need to have some kind of load balancer and things like that. And also, there's an even bigger problem. Most of the time, we don't need to scale everything. We just need to scale two small things of our application, but we need to scale all the other services of our application, because everything is glued together. And also, what if something fails? Even if smallest thing fail, that can affect the whole application. And whole server can go. There are ways to solve that, of course, and one of the most popular way is microservices. It's like Unicorn or something like that, something that exists, but most of us never used. So we still have some kind of our server. It can be a cloud server or whatever. But now, how do we build some microservice applications? First, we should put each part of the application on a separate, isolated machine. And we build our application. Then it works fine. And it's quite easy to scale it because we can just scale things that we really need. That's cool. Also, if we don't need something, we can just remove it. Everything will continue working because those are separate things. And of course, if something fails, it's not exactly the same that we have with the monolith application because that thing will not affect anything else. And of course, if we have other copies of that service, other users will just continue using them. But what if the yellow part fails? Then if we don't have a copy, we'll still have a problem. Smaller problem, but still a problem. Also, one more question. Are serverless cheap? I don't think so, because try to explain to your client that you need 15 of them when you start building your application. It's not working for me. So how do we make those things cheaper? Basically, by bundling all those things together. And when we want to scale it, we can just scale some things, but again, we want to bundle them together to make it cheaper. And again, if you still need to scale it, we can do that. There's still some waste of space, but it's still cheaper. Also, we bundled everything together, but if something fails, it still can affect some other things on that machine. Of course, not if you're using Docker or something like that, but that's still a bunch of things that you need to think about. So just imagine that we can build our applications without that 4x4 wide piece. How that would work? So basically, we just build our services the same way we did before, and it just works. Then if we want to scale that, in that situation, we wouldn't care about the server anymore. We would just add additional services like this, or even more of them, or even more of them. We don't care about that. Then if we want to remove something, we still can remove it without affecting anything else. Now, imagine that someone is doing that scaling for you. So you don't need to think about that. That would be really great, right? Also, what would we get with that is some kind of automatic failover. So if something breaks, it will be automatically replaced. Sounds really great, at least for me. And there's even better thing. Just imagine that you don't need to pay for things that you don't use. So if you don't need, for example, purple brick anymore, you don't pay for it. That, for me, sounds perfect. But we kind of have something like that. And it's called serverless. There are some problems with serverless. Of course, most of the problems are with the name. And because everyone is saying that name is wrong because we still have serverless. I would say less is more, so serverless can be more servers, right? Yeah, there's a bunch of different things with the name, but there's also one really good quote, like we should call it Jeff or something like that, because we should focus on the technology, not on the name. And I really like quoting my friend, Gojko Adžić. He has awesome quote. So serverless for servers is the same like wireless for wires. There are still wires, but you don't care about them anymore. You don't need to drag the wire with you. They are somewhere in the background, and someone else will handle that. So it's the same with serverless, exactly the same. So cool. We kind of understand what is serverless, but how does that work? So is it some kind of magic or something like that? Actually, no. It's simply event-driven system. What does that mean? Just imagine that we have our function as some light bulb, and we have some trigger, and when we hit that trigger, our function will start working. Also, the same thing like a light bulb is that you don't pay for electricity if your light bulb is not working. The different thing is, of course, that you need to still buy a light bulb, but for serverless, you don't need to buy a server in advance. So the other thing that is quite the same is that you can probably turn on your light with many different things like Amazon Alexa or your phone or some sensors or whatever else. And also you can have multiple triggers for the same Lambda function or same light bulb. But beside that, serverless is a bit different because if you need more light, it will scale automatically. So it will give you more light without doing anything. And also, if something breaks, as we saw, it will be automatically replaced. So our functions are in some way like a light bulb, but not really. Also, they're stateless. They're like goldfish. Because by default, your Lambda function can remember some information up to 3 seconds because that's the timeout that we have for Lambda functions. So we need to keep our state somewhere else. It can process things up to 5 minutes, but by default, it's really, really small amount of time. And also, but yeah, most of the time, we are not doing something with light bulbs or doing something with goldfish. So how does that work with the real system? Let's just imagine that we have some really simple web application and that someone is using our API from mobile app or something like that. And some user want to sign up. So how does that work? First, some request will hit our API. Then we'll use our, for example, sign-up controller that will check, validate everything, then check the database. After that, it will sign up user. And then we want to send an email. But since we want to keep it as cheap as we can, we don't have a queue or something like that for emails. So basically, we have the same service that will just send an email. And after that is sent successfully, it will just reply to the user that everything is fine and that he or she is signed up. But the problem with that is if just the small thing of our application fails, it can affect everything. So in this case, email service is not working. Our user is signed up, but mail is never sent, so our API response will return, for example, status 500 or something like that. So if user try to sign up again, he or she will not be able to do that because they're already in the database. But how would we do that with the serverless application? Is it that different? It's not. Basically, we have some service for our API. This is the Amazon setup, but you can do the same with Google or with Microsoft and some others. Basically, we have some API gateway that you will hit with your request. Then that will trigger our sign-up function. That will do the same things. It will validate everything, write that to the database, and basically just return the answer back to the user. And we can use database to trigger another Lambda function that will use some other service to send an email. And if email fails, we doesn't care about that because our user will still get notified inside the application that he or she is signed up, and we can even have some kind of queue or something like that directly inside Lambda because there is some kind of dead letter queue that will just keep retrying after some time. But what is in that box? How does that work? So basically, it's like some black box or something like that. And let's see how does that work. So basically, we have our API gateway with some HTTP request. Then we have a simple Node module on this side. It's just a simple module that exports some handler that has a function that will receive event, some kind of context, and a callback, and that's it. And then when something hits that API, it will just send a simple JSON to our function. That will be our event. And Lambda context will be some information about our Lambda function. And callback is simply something that will just, allow us to return something back to our API. And how we do that? Simply by just returning some JSON that will just return another wrap JSON to API gateway. And then it will have body, some status code, headers, and things like that. That's it. It's really simple. It's no magic or something like that. But since we are JavaScript developers, let's see how does this work with Node.js, because everything works with Node.js, right? First, I would say that it fits Node.js really, really good. It's almost perfect. There are some good things with Node.js. And the first one is, of course, good startup performance. You can run multiple different languages on AWS Lambda, but the best thing with Node.js is that it will give you the smallest latency between the request and your function that is running something, because it's really fast to start Node.js. It's much faster than, you need much less time than you need for, I don't know, for example, Java or something like that. So that's really great. Also, Node is about small modules. And that's great because we want our Lambda function to do some small things, so small modules works perfectly with that. Beside that, it's really good for low CPU and memory. And by default, AWS will give us just 128 megabytes of memory, which is really small, but Node.js doesn't require that much memory, so we can process more things with just the same container. Then it's single thread. Our machine is handling just one request. If you have another request, another Lambda function will do that, so we don't have multi-thread environment for that. And it's really easy to learn. But of course, some things are not perfect, so there are some problems with Node.js. And first one is the most powerful thing about Node.js. It's async. And why is that a problem? Not because Lambda can't handle that, but as I said, one Lambda function or serverless function will handle just one request. So it doesn't need to be async at all. But we still need to be async, and that's a problem for a lot of users that are not really proficient with Node.js. We have some JavaScript library that works with serverless, and most of the problems on our GitHub are the problems with handling promises and things like that, so breaking promises chain. So that's a problem mostly because of the developer experience. Also, Node.js is built for scalability and things like that. You really don't need that with Lambda, because one server is actually one function or one machine is handling just one request. You don't care about scalability. That's something that Amazon will give you, or Google, or Microsoft, or anyone else. We have small modules, but after some time we can have a really big modules, not module size. So that can be a problem too, because we need to upload everything to our function whenever we upload a new version of a function. And Node.js is really easy to learn, but it's really easy to make some mistakes with it. So, yeah. And this is Hello World from AWS website. And if you take a look at it, it's really simple. It's just exporting handler that we already saw and doing callback. That's it, nothing special. It's just a few console logs that we really don't need to. But if you try to deploy this, and if you try to follow the steps from AWS website, you'll need to do following. First, you'll need to create Lambda function. Then you will need to zip everything you have, including Node modules. And then you need to upload that as a zip file. After that, you need to create API gateway and some API. Then to tell Lambda function that that API will trigger it. Finally, you need to set some kind of permissions and to allow those Lambda function and API gateway to communicate and a bunch of other things. And if you take a look at that article, you need more than 10 minutes just to read it. And it's still better than setting up the server, but it's boring. I don't like reading many things just to deploy simple hello world. But luckily, there are some frameworks. Let's call them frameworks because they're not really frameworks. They are more like libraries to help us to do those things. And the most popular one is Serverless Framework. The other one that we'll talk a bit more about is Cloudya.js because that's something that I'm much more involved with. And finally, there's Apex. And Apex is really good because it allows you to deploy both Node.js and Golang functions to AWS Lambda. All of them are working with AWS Lambda, and Serverless Framework now has a support for Microsoft Azure too. So let's talk a bit about Cloudya.js. And it's not small anymore. We have almost 70,000 downloads so far, and it's growing every day. I need to update that slide whenever I'm talking about Cloudya. And what does it do for you? First, it allows you to build microservices. You can build different kinds of microservices, of course, easily. It allows you to build simple APIs or not so simple APIs. And finally, it allows you to build chatbots. you can build chatbot for 10 different platforms. So you can build something that will be chatbot for Facebook Messenger, then for Viber, I don't know, many other things, and you'll have just one Lambda function that will handle all those things. So let's see some characteristics about Cloudia. First, you remember those 10 minutes about reading things, how to deploy everything? Cloudia will allow you to do that with just a single command. You just need to use standard Node.js modules, so there's no any special thing that you need to do. Also, no boilerplate. There's simple rules that you need to follow, but we don't want to push you to write your application in some specific way. Then it allows you to manage multiple functions easily. And finally, it allows you to start working with it really easily. So let's talk about that flat learning curve. What does that mean? How fast you can build something with, and how flat is that curve? Let's see. Let's build a simple application. First, you need to install Cloudia globally. You know that. It's really easy from NPM. So then there is one manual step that you need to do just once, and you need to set up credentials. It's really easy. It's not anything special. Then let's create some folder and enter it, create a package.json file, and finally install Cloudia API Builder. That's it. So that's everything we need for it. And how do we write our application with Cloudia? So this is the simple application. I found some facts about Amsterdam, so we'll try to use that. I have a JSON with 20 different facts. If we want to build our API, it's really simple. We just need to include the API Builder to make an instance of it, and to create some route, for example, just slash, and to return all the facts. And finally, we want to export that because Cloudia will fit your module between request and response. Something like some kind of, sorry, my brain is not working for that. The same way that Express is doing with middlewares and things like that. So if we want to deploy that, we just need to simply run one function. It's Cloudia create. You need to specify region, and finally, you need to tell Cloudia which file to read. Since our file was API.js, we'll use API module API. We don't use .js extension. After maybe a minute or so, we'll see something like this. And we have a big URL here, so I just made a shorter version of it. And if you want to test it, it will show you something like this. If you want, you can try. So basically, it works. With one command, we have a public URL that works. We also have cross-origin requests that are set up and things like that. And what if we want to update our API? Doesn't need to do just one thing, or we can do multiple things with it. Let's try. Let's build a few more things. First, let's try to get a fact by ID. And the other thing, let's try to get a random fact. And it's really easy. Well, we'll add 2 more routes, and that's it. If we want to deploy it, we'll do Cloudia update. If we go to /random, we'll see that we have a random fact. And if we do, for example, /14, we'll have a fact with ID number 14. Simple. The code is on my GitHub, so if you want to check it out, feel free to do it. It's really simple code, but if you want to improve something, feel free to send a pull request. OK, so how can you learn serverless? Basically, it's really easy. The easiest way to do that is not to read about that, is probably to pick just any of those 3 frameworks and just to play with them, because there are many different examples on all of their websites. But the funniest way to learn serverless is probably to go to a serverless.camp, because we created a small workshop that allows you to create small serverless functions that will run one of those 2 tanks, and then to play against someone else's function. And it's really fun. We had a few of those workshops so far, and people were really happy. Also, just go play. It's easy. You will not break anything. At least, I hope you will not. And let's just quickly go through a few important steps, because we don't have much time. First, why is it important? Why do we talk about serverless? And why is it important for you? First, you don't have to maintain the servers and things like that. So if you want a side project or something like that, you can really fast get started with that and have something online, and then you can evolve that into a real application really easily. Then we have a financial incentive. Why? Because there's a really great explanation on this URL. It's, I mentioned Goico already, but the thing is that you don't need to sell anything anymore to your clients or your boss or something like that. You don't need more money to build a good architecture. Finally, we have some architecture that will push you to build a real microservices without punishing you by a bigger bill. Also, price for AWS Lambda is really cheap. It's 20 cents for a million requests. So imagine that you have API, it's almost million requests for your API, and first million each month are free. Also, they're paying, you're paying something for the traffic, but again, you will not hit this limit that easily because unless you're doing some image conversions and things like that. So, other thing is true microservices. We can finally build the microservices without thinking about the infrastructure, scaling, and all other things. Finally, we can just build a service that is doing just one thing, nothing else. Then it has auto-scaling, and also it can it does auto-failover for you. And you can focus on your business logic. You don't need to care about servers and things like that anymore. And of course, it's not good for everything. So let's see, when should you use it? And more important, when shouldn't you use it? If you have a real-time application with WebSockets, this is not for you because you don't have server that is running all the time. So WebSocket connection will not work directly. You can use something else to make it work, but it's probably not for you. If you need to build some really low latency API and to guarantee your clients that your latency will be less than 100 milliseconds, it's probably not for you because it can be a bit higher or a bit lower. You're not able to guarantee that. Then if you need to do some special customization of your server, that will not work because you're not able to do that. If you're building medical application, you shouldn't probably use just serverless for that. You can use it for some parts. If you need some really long-running tasks, it's not for you. And for complex computing, it's really not for you. What is it good for? First, for web APIs, as we saw. So we can probably use it as a backend for single-page apps. Then chatbots, we saw that it works too. You can do quick prototypes that will evolve to real solutions. You can process any kind of files, maybe do Internet of Things, and many, many other things. And we need to hurry up, sorry for that. So how can you start with that? You can start with your side project, basically by using AWS Lambda and AWS ecosystem, or you can use your existing app and just move some small things to serverless. Soon after that, you'll try to move everything to serverless, probably. It's not good for that, but you can try. So this was a bonus, but we don't have time for that. Basically, it's secure because it's really hard to hack something that takes just a few hundred milliseconds to execute, and there's a few other things. But we'll skip that now because we don't have enough time for that. There are some problems still, but it's secure. It's much more secure than standard servers, and it gives me a better set of problems to deal with. And let's just summarize this talk because we don't have any more time. So what's serverless? It's fully managed function as a service that allows you to focus on your business logic, and you don't care about servers. It's event-driven. So you need some event to trigger your Lambda function. It's auto-scaling, and it has auto-failover, which is great. It works with Node.js, so you can play with it. There are 3 major frameworks for Node.js, at least I don't know for any other. And go try it, because it's really simple to play with it. And that should be the end. Also, I would just like to mention there are still servers, but you don't need to care about them, so that's great, at least for me. So that was it.